So this is Brad here at ANU, and I'm with Ryan and Alec and Lish from ABC Canberra, and we were talking about the colors of light and how we can see more than our eyes and what this means for astronomy.
That's exactly right, Brad. So we're used to seeing the visible spectrum of light, so the rainbow of colors that we can see with our eyes. But of course, we can actually go beyond that to see the full spectrum of possible colors, and we really want that for astronomy because we want to get as much information out of the light that we can. So we can go down the rainbow of colors and just off the end of the red part of the rainbow, and that's called the infrared. Now we're lucky enough today to have an infrared camera to show us what we look like in infrared light. So what can you see here, Lish? What do we look like in infrared?
We look hot and cold. Cool, let's say cool. I can see, like, so my face is red, but my glasses are cool. Well, we knew that.
So what we're seeing here is the heat that we're producing. So everything that is warm produces infrared light. And so your glass is actually blocking part of the infrared light, and there are other things that we can use to block infrared light as well. So Ryan, if you want to block yourself here with this space blanket, which is designed to block infrared light, what can you see now on the screen?
Reflection, so I just see, I can't see Ryan, he's completely disappeared, but I know he's there.
Yeah. He's totally gone. So that blocks both infrared and visible light. So now we can look at what it looks like with a plastic bag. And this is just a regular garden bag you can buy. So Ryan, if you block yourself, you can see you block out all the visible light, but what can we see with the infrared camera?
Yeah, I can still see him there.
He's still
even
there.
Though you probably can't see him in the camera.
So the infrared light from Ryan has made it through to our infrared camera.
So how does that apply to astronomy?
This is a very useful tool in astronomy because it lets us examine things which would appear blocked to us in other wavelengths. So in space, there are big collections of gas and dust called nebula, and we, with visible light, can't see through these nebula, so we'd have no hope of understanding what's inside. But with infrared light, we can actually probe inside of these things to find the warm dust which is all swirling around from perhaps new stars and planets being formed. So with infrared light, we can study the formation of new worlds and new stars. And there are lots of astronomers up here at the ANU who work with infrared light to discover just that.
So in your telescope, do you have an infrared light detector?
So you can build cameras specifically designed to detect infrared light. But the crazy thing is with infrared astronomy, you have to be really careful that you're not detecting your telescope itself from being warm or even the atmosphere for being warm. So infrared astronomy is both a very hard thing to do, but a very rewarding thing to do scientifically.